Okay, this learning target, I can graph radical equations. I have written out the standard form of the radical equation, y equals a square root the quantity x minus h plus k, or we're more familiar with the parent function of y equals the square root of x. Using the starting point form of this, because there isn't actually a vertex here, but there is a starting point. H is a horizontal shift, k is a vertical shift, and I have gone ahead and graphed the y equals the square root of x, the parent function. So this is our parent function. And notice that this graph starts at the point 0, 0. So we're going to use the fact that the parent function starts at the point 0, 0, and the fact that h is a horizontal shift and k is a vertical shift to graph different radical equations. So the first one we're going to look at is this one, and y equals -5 plus 2 root x. Now, they have actually put the k in the front. This is your k, and I'm going to relocate it so that it's used to looking like I want it to. So I'm going to move it to behind the radical. So I'm going to rewrite this, y equals 2 root x minus 5. Making sure that I don't put this -5 under the radical because it doesn't actually belong under the radical. So what I'm looking for is normally I start my parent function at the point 0, 0. But this one has a vertical shift. There's a k here of -5, so we have a vertical shift. And that means that my 0, 0 is actually going to go down 5. I do not have an h value, so I'm not going to move horizontally, but I am going to move down 5. So from 0, 0, my first point goes down 5, and that's my starting point. So I'm at 0, 0, 1, 2, 3, 4, 5 down, and my start now is here. My starting point. For my next points, I'm going to choose a value for x, and I'm going to substitute that into my given equation. So I'm going to first choose x equals 1. I'm choosing x equals 1. Substitute that into my equation to find y. Y equals 2 times the square root of 1 minus 5. Y equals 2 minus 5 equals -3. That means I have a point, 1, -3, and that's my second point. For my third point, and I do want you to have a minimum of 3 points, I'm going to choose another x value. This time I'm going to go a little bit bigger, and I'm going to go with 4. So I am choosing x equals 4. Substitute that into my given equation. Y equals 2 times radical 4 minus 5. Y equals 2 times 2 minus 5. Y equals 4 minus 5 equals -1. My coordinate is 4, -1. 1, 2, 3, 4, -1. Now that I have 3 points, I am okay to graph my line or my curve, and it is a curve. And it's doing something like this. Okay, so there's my first example. Okay. For the second example, I want to use the equation y equals 2 square root of x plus 5 plus 1. So let's get an x and y axis on here. Okay, for this equation, we do have an h and a k. Our h is 5, and actually, because the original function says minus h, we're going to say h is negative 5. H equals negative 5, meaning that I have a shift to the left. Okay, my k is 1, so I have a shift up 1. So normally I start here at 0, 0, but instead of starting at 0, 0, I'm going to move 5 units left, 1, 2, 3, 4, 5, 1 unit up, 1. There's my starting point. Now I'm going to pick 2 values for x so that I can have other values to put on my graph. So I am going to choose, I'm choosing to let x equal negative 1. I'm substituting that into my given equation, 2 times the square root of negative 1 plus 5 plus 1. Y equals 2 times the square root of 4 plus 1. Y equals 2 times 2 plus 1. Y equals 5. So I do have the point of negative 1, 5. So negative 1, 1, 2, 3, 4, 5. That's way up here. I'm going to choose one more point. This time I'm going to choose something between my 2 points here. I'm going to go ahead and go with a negative 4. So I'm choosing x to equal negative 4. Substituting that in, 2 times the square root of negative 4 plus 5 plus 1. Y equals 2 times the square root of 1 plus 1. Y equals 2 plus 1 equals 3. So I have the coordinate negative 4, 3. So negative 4, 1, 2, 3. And I start here and I'm drawing my curve. And it goes off that way.